So do we start or? Yeah, we can start. You ready? Okay. All right. So I think you guys are the diehard fans of our panel, it seems, who are here now at this hour. Thank you for coming. I think this is the panel which kind of brings many of the discussions we have had today together in terms of what do you use big data, cloud, and mobile services or service-oriented architectures for. So what we'll talk about is the mobile and IoT services. You see the panelists here. We have Roberto from GE. We have Teresa from Accenture, Rong from IBM, Manish from Rutgers University, and myself, Nimish from Ericsson. So I think from just to set the context for us, at least from Ericsson's point of view and many of the others in industry, we are looking at this 50 billion connected world that will come about by 2020 or sometime thereafter, which will basically transform the industries and individuals in many, many ways. So what we are looking at is this transformation opportunities when everything is connected. And this creates many challenges as well in terms of how people will work, what kind of wealth distribution will be there, how the society will be impacted, how do we deal with the energy and sustainability, dealing with the privacy of the data and information, as well as reliance, more and more reliance we have on the digital domain or digital world as per se. And also the inclusion of all parts of society. So this is the context in which we want to look at the technology that are important for us to deal with. And this is where, as I said in the beginning, many of these areas that are part of this conference in terms of data-driven service-oriented computing, the DevOps model that we heard from Google about, as well as others. And from Ericsson's point of view, what we are looking at is when all of these 50 billion devices are connected, how do you provide more of a programmable and on-demand infrastructure for the services, IoT and mobile services? Today, many of the networks and services are designed for a static configurations, more or less. But as these workloads that come about for the challenges I talked about, we will see a need for more and more on-demand, highly shared and distributed infrastructure. So panelists today will kind of address many of the areas that I'm referring to, as well as some other ones. So we'll start with Roberto from GE.
So thank you, Manish. So as he said, I'm Roberto from GE. In particular, I'm from the Collaborative and Mobile Lab. And our focus is mainly on the user experience. And so I'm going to talk about mobile services and IoT from that point of view. So first, a little bit of background. This is our CEO, Jeff Immelt, in the conference last year. And his vision is clear, right? The goal of the industrial internet that GE is pushing forward is basically to connect people, data, and machines. So it's not only about data and machines, but also people. People is a very important part of it. And why is that? Well, GE is a big company in different sectors, and including aviation, healthcare, manufacturing, mining, oil and gas, power generation, and so on. And we build not only machines, but we install those machines and we service those machines. And people are an important part of this service. As part of the industrial internet, we are instrumenting different machines. We are collecting this data and connecting the different machines that GE provides. So there will be an estimate of 50 billion machines by 2020, and there is a twofold data growth in the next 10 years. And this data that's being generated is not only sensor, historic data, but also content and machine data. It also includes ERP systems, CRM, and all the other types of information that surrounds the data management or the systems management. So some numbers here, for example, there's 1 terabyte of data per flight produced by those turbines, by each turbine. There's about 9 million data points per hour in typical locomotive managed by GE, and 500 gigabytes of data per blade by gas turbines. So we have this immense amount of information, and estimated is only 3% is being parsed and used right now. And our goal is to really increase that one and add value to our users. So what GE Software has been doing is building this industrial internet, and is particularly building Predix, which is these operating systems for the industrial internet. Predix has two main components. One is the machine end, the machine side, which is Predix machine, the edge computing, and the other is the cloud itself. We are using some standards and such as Cloud Foundry, and we are building specialized services as microservices. And we're going to use those microservices to support different applications, such as asset performance management on the top. So you see the mobile layer. And really, the applications we are looking at are mainly in the mobile ecosystem. But again, I am from a user experience point of view, and that's our vision. So our vision is to leverage on mobile and wearable computing to connect the industrial internet data and insights, so that information that we build through analytics, to people at work. And we want to do this in a contextual way. So imagine having everything you need, whenever you need, when you need it, while you're working or while you're performing your job. So and even before you know it, we already have the data you want. That's our vision, that's our goal. And this is a typical field engineer. So how are you going to deliver that information to our field engineers? We're going to use wearable computers, we're going to use mobile computers, virtual reality, sensors, and all sorts of IoT devices to connect people to the insights in the cloud. So what are the opportunities in the industrial domain? So if you look at the IoT for the consumer market, I mean, people have been talking about a lot in terms of health, fitness and health, but I see the big opportunities are actually in the industry. For example, there are many opportunities in effectiveness and efficiency optimization. The ability to show the field workers their work scope, to provide the right information at the right time, to allow them to do remote troubleshooting by open connections to remote help desks and share data, share pictures, and interact directly with experts that may not be remote. There is also this big potential for data collection in the field, for documenting your work, and for visualizing this data in the field. Also, there are lots of opportunities in safety and security. You know, industrial domains are very safety aware and security concerned. And in particular, in this kind of services engineering, people are very busy with their hands. So the traditional mobile device that you have that interact with your hands is not usually adequate for those settings. So we've been experimenting with wearable computers and all sorts of wearable computers, including vital sign monitoring, environmental monitoring, and alerting for dangerous situations. For example, many of our engineers work in nuclear power plants, and it's very important to be aware of your environment, of any leakage or any hazardous material while you work. This IoT provides this ability, the potential to monitor your environment and generate those kinds of alerts. And finally, training and quality assurance is another potential domain in the industry. As I said, there's a lot of potential for knowledge capture, to transfer the knowledge from experts to novices and students. A lot of potential for certification using virtual reality environments, training in settings that reproduce the actual world, but you're not in the actual world, and documentation and compliance and so on. Okay, so I put together some of mobile apps and some examples of some prototypes we developed to prove some of those concepts. The first one on the right is called My World, and it's basically an app that the field engineer or field service engineer uses to inspect a machine, and goes close to the machine, scans QR codes or RFIDs. And on the right side, you see all maintenance history of the machine, and on the left side, all the tasks that the user had to perform to provide maintenance at certain point. And it also allows you to update in real time the progress of your maintenance. In the bottom is another system called Ask an Expert. That is basically a communication suite between using video, voice, and document sharing between field engineers and remote experts. So you can interact with them and solve problems you may find on the field, on the spot. Another domain that we've been looking at right now is augmented reality. And augmented reality has two aspects, one for training and another for at-work guidance. So you can use for novice students, or you can use for inspection and for work scope analysis on the spot. And then I put together also some challenges that we have in order to make this vision become a reality. One of the first challenges is these wearable and mobile systems. They have to conform to security equipment and that FEs have to use. They have to wear helmets and glasses. They usually have to have a small form factor. They have to be able to fit in that kind of equipment. We don't want to add more weight to the regular field engineer. And they also have different power and CPU constraints. We did some experiments with virtual reality glasses and others, and those devices tend to heat up a lot because of the processing, and they usually don't have enough battery power to last throughout a shift of 8 to 10 hours. So those are one of the challenges that we are facing. Another challenge is mobile QoS. Once you are in the field, it's not always the case that you have connectivity. Connectivity may be very scarce, or may not be there at all. So how do you provide those experiences in an environment with such a very flaky connectivity? Also, naturalistic user interfaces like gestures and voices are very important in this domain, because your hands are busy, you're working on heavy-duty machines, and you want to provide different types of interaction so you can leverage your wearable devices. Another problem that we may face is context in false positives. The problem is you're trying to figure out what the user's intention is. So how to do that in a physical environment? How to leverage the work scope to do that? How to prevent those false positives so you can provide information at work. If you fail to do that, you may certainly be rejected by those workers. And also, as we are collecting all the information in the cloud, we are filling the cloud with all sorts of data, how do you pick the right data to the right user, and how do you handle this big scale of data, summarize in the right way in Factory to deliver on the field to the user? Safety is another concern, or distractions or problems. Suppose you're wearing a wearable device, a virtual reality glass, working in a very dark place and with all sorts of hazards. You may well hit something or get some accident just because you're distracted to it. So how do you handle this in terms of a wearable device or in terms of software? And security in IoT is always a big concern. So once you start connecting machines, you get all this data, but you also open up for possible attacks. Also, you have now this data in mobile devices or in wearable computers that people are carrying around. So how do you manage this security? And finally, there may be lots of cultural change and some resistance of people in adopting this new technology. So how do you introduce technology? How do you add value? How do you show the value so they can so the technology can be adopted and they can reap the benefits of it, right?
Good. So maybe, Teresa, you can come and talk about what Accenture is doing in this space.
Hi, my name is Teresa Tung, and I lead global R&D for IoT, Industrial Internet of Things at Accenture. So for those of you who don't know what Accenture is essentially Geek Squad for your Fortune 500. So that means that when they need help building something like, what does this industrial internet mean to my business? Part of what we do is we help consult, figure out what the strategy is, and then to implement things. I wanted to use today's opportunity to talk about impose a problem for the academic community. So I want to focus on the platform itself. So this is a platform that sensor data from mobile devices, from your Internet of Things, hits. And this platform would store the data, do analytics on the data, and then more importantly, allow others to be able to build applications on top of that data for use cases that are not even there when you first design the data, right? When you first build the platform, many of the use cases and the promise of IoT is that things adapt and you have the data to meet those needs. So to do this, it's about, we talked about cloud, we talked about DevOps, it's about agility and interoperability and the speed at which you can reuse the data and the services that you have to do something new. And so the particular problem I want to focus on today is on the ability to find and access data. So we talked about a platform. The sensors are out there. The sensors are hitting this platform. How do you now enable the domain-specific contextualization of this data? So we pose a problem, we call it data harmonization. And this is essentially marrying the concepts of data virtualization and contextualized. So if you think about, this is a scenario that we have today. So when I talk about the IoT platform, a lot of our clients say, we have a Hadoop platform, we have a data lake, we're done. Throw all the data in there, I can use it later on. This fails in terms of many things, in that oftentimes it's mainly the sensor data going in there. What you have is actually an ecosystem that looks like what I have on the screen. First of all, the data that you need isn't just the sensor data. It's actually that same sensor data needs to be combined with customer contacts, with site maintenance records, with historical readings to be able to make a decision about the situation. So if I have a particular instance, a particular engine instance, I would combine that same sensor data with all the other sensor data around that physical assets. I would look at maintenance site records, maintenance contacts. Then I can essentially schedule preventative maintenance against that piece of equipment. That same sensor data, when combined with the family of data, so let's say this is made by a particular manufacturer, let's say it's GE, right? I want to see how well this particular asset performs in my fleet. So I want to combine that same sensor reading about that particular instance with all that in the family, and then also combine it with certain environmental conditions, and then eventually schedule something based off of how I work with GE to essentially maintain that fleet. In the same case, that same sensor data is used differently based off of context. It's brought in and enriched with other data. So it's no longer just the Hadoop ecosystem, the data lake. It's no longer just adding something like Cassandra or Dynamo, some sort of time series repository. But it's actually that contextual layer, this graph that I have overlaid on top of a very heterogeneous data system. And you're going to have a data lake. You're going to have a time series data store. You're going to have a blob store. You're going to have an enterprise data warehouse. Because that's where the data that you need to essentially make your decision resides. Right? So the name of the game is making this a very easy thing to do. So the data comes in. It's going to be coming into many different platforms. Some of it is because you don't own that data. Customer contacts are probably going to go in an enterprise data warehouse that maybe you as the IoT guy doesn't own. You would own the sensor data, so that's your domain. But now you need to enrich it and to be able to discover and explore that data along with all this other data that may not be yours. And so what we do today, what we as consultants do, oftentimes the way that we do it today is we create a view of the data. It's a static capture, and we essentially bring it all together. And now we have a view, and we're like, okay, we're going to do analytics off this view. By the time you make that view, the data is already stale. So we need to take a more real-time approach to this. So my challenge to the academic community is think about this like the way that the internet scales. And part of it is that you need to be able to explore and exchange these concepts at the high level, that I have customer data, you have customer data, you probably have a subset of customers that overlap. How do I essentially exchange that in a way that's meaningful, that's discoverable for an application use case, in a way that abstracts away the fact that underneath, this data is actually stored in very different ways. So if you go back and harken back to the internet OSI model, the internet model, you have your physical link layer that tells you things like how are the physical devices, maybe how are the sensors actually where the data comes from. You have your data link layer, you have your transport layer for exchanging data and finding the data, accessing the data. In this case, we have different data stores with different technologies, with different governance. So think about that, and we have been thinking about that. So we want to be able to now support a contextualized data management. So it's really this picture that I'm painting, that underneath there's a lot of different data stores owned by different organizations. On top, you have data that's connected to each other that needs to be discovered with context, right? Whether I'm looking at the fleet or I'm looking at a particular instance, it's going to change the data that's brought to bear. In one case, that other information is just noise. It should be driven from the domain semantics. So from the purpose of someone trying to access and use this data at the application layer, they should just be able to say, I care about temperature, I care about age, I care about the manufacturer. They don't necessarily need to know that that temperature data actually comes from an API, comes from a patch, comes from wherever. You need to track that in the platform for lineage and governance purposes. But from the purpose of trying to find and access the data and to be able to imagine new use cases and application of the data that you have, you don't really need that. right? You need to enable that and track it for management. And then at the end, you need to support the configuration. I said virtualization here. It doesn't have to be that. It just has to support the interchange and the interoperability. Again, think transport, right? Think exchange. How do I share data in a way that's now discoverable, extensible, be able to use it together? So what we've done is we've taken a first step at this, and we took our inspiration from the way that today's modern search engines work, the way that linked open data works, and we may be wrong, but here's where I'd like some help. So we took a linked data model where we're using the domain metadata, the descriptive metadata around things. Here I have this picture in asset hierarchy. So this is actually done for a client. I just have a very simplified view of this, but this is for a smart water network. And in smart water networks, you have a logical domain, something called a district meter area, which is essentially a logical zone. And within a district meter area, there's water supplied by a principal main that draws from a trunk main, has a measuring sensor called a district meter. That district meter measures things like pressure and flow. This is typically stuff in a domain model that what we do today, this knowledge is actually in the mind of a subject matter expert. And what I do as part of my work is we talk and we interview this expert for many hours. And some of the times we get everything, some of the times we don't. There's a different expert. There's an IT expert who knows where all this data is stored. They're in different tables. They're in some weird systems like SAP, which you don't learn about in school, but it's really hard to work with sometimes, right? And there's open source systems, which we do a lot as grad students, where we're more comfortable with. But in any case, you need to be able to access the data, and you talk to some IT guys that gives you tables, gives you CSV files that are really big. And then you talk to the domain expert to understand how this data makes sense. And only then can you start to think about building a platform, building an application, building a use case. Well, this is a lot of investment before you even start thinking about how the data can apply, just to find the data, understand its context, and then to access it. Right, so we're suggesting we capture this knowledge ahead of time in this linked data model, indexing that domain data with where the data is stored. So the time series data, pressure and flow, I should be able to index whether that data in this example is stored in Cassandra and Dynamo, right? The same way you would index URIs. And to do this, what does this enable? This enables now that we capture this knowledge. So you still have to do that exercise where I'm interviewing experts, finding things out once. But after this, the next guy doesn't now have to go through that same exercise. Let's use this to essentially help accelerate the discovery of data in a way that's contextualized. So that particular model, we're proposing using it in a couple ways. So the middle is what we have today, right? There's a graphical domain connection of data overlaid on top of this very disparate, heterogeneous data store environment. And that's going to continue to evolve, like I said, for governance reasons, for bespoke performance trade-offs. There's always going to be that new data platform coming out, Mongo, Cassandra, Hive. So that's going to continue to happen, and we're going to continue to want to differentiate on that. But outside of this, we can use this linked data model to help us manage this environment, right? We talked about how we can find and first route on ingestion, where does that data go? Right? So if I know this is of type time series, I know this belongs to my organization, it should go to my data store. As it's coming in, we want to index it so that now it's discoverable for folks to be able to now think of new use cases. And then on consumption, how do I configure that tier? Right? So if you're doing some sort of query plan, you would like to actually join across the different data stores in context. I want to say, give me all data related to, users or people at this conference. So it's joining who's at the conference with, let's say, your Twitter data, right? I don't want to just see everything, and I only want to see it for when you're at this conference, so temporally. Oftentimes, that's going to be in different data stores, and you want to be able to allow this sort of contextualized query optimization. So another way that we think about using it, and I'll leave it with this final example, is for exploration. So I try to motivate with, this is a problem around finding data and accessing data. So we're all familiar with your modern search engine. And in this modern search engine, you typically have your search results listed. They're ranked. It's great. But you also have these cards, and that's really applying the knowledge graph, the domain ontology. Because I know this is a person, I'm going to assemble the data. So if I do a search for Clint Eastwood is a person. He has a birthday. He has a family. He has images of him. I know Clint Eastwood is an actor. There's certain movies he stars in. I know Clint Eastwood is a director. So based off of what Clint Eastwood is doing, I'm able to now map the data that exists on the internet into this contextualized view. So if you think about what I described, how long it took, these interviews that we have to have happen to be able to just find out, in this case, what is Cockfosters? Cockfosters is a particular district meter area in the UK. But if I have captured already what a district meter area is, I should be able to now cast my data in a way that helps accelerate understanding for the users. Right? So as a user of this data, I don't care how it's stored. I don't really care where it came from in the beginning. I will care later on, so I want to track that provenance. But I just want to show me all data about Cockfosters. And to be able to have it in this case, Cockfosters is a DMA, so it has a logical zone. There's a geographical map now that makes sense to actually show that. Cockfosters has people associated. That zone has contacts, people who are managing that particular area. Cockfosters has particular equipment that's associated to that domain. As new equipment comes aboard, so let's say tomorrow I suddenly get principal main data, that should just appear here, right? You can even write a little job that says, I like this, I want to subscribe to Cockfosters, it's an area I live in, I care about it. So as new data comes available, we should be able to now notify folks that there's a new use case, do you want to use it? So this is just one particular problem, right? So using this linked data model to be able to find and access the data, using it to be able to now index data and manage that environment with heterogeneous data stores. We think it could be applied for other things later on, like trust, like management. So this is just posing a problem. We don't have all the answers for it, but I wanted to pose it to this community. Thank you.
Well, thank you. So I think as you can see, I think from the industry's point of view, we are looking at different kinds of problem other than big data analytics as it is studied in the past in the search domain, primarily from Google's and others of the world. So there is I think the IoT and mobile services poses a different challenge, and one of the main part of that is the technology itself maybe needs to change, and maybe Ron can talk about some of those aspects as well.
Okay. Good afternoon. I'm Ron Chen. I'm going to focus on one aspect. I think that appears underappreciated or underestimate the effort required to manage an IoT-enabled cyber-physical services. And hopefully, at this panel could help us to accelerate the needed service community technologies to work on that. Before I talk about the requirement and trends, I would like to share with you some important past accomplishment we did from the value creation perspective. That is driven by the cost saving and innovation. The three examples I put there are also very inspiring. If you have not been exposed to those systems, I encourage you to spend some time to understand how we come from the old days. The first one regards the telephony cloud. I kept reminding people the most successful and mature cloud service we have today is a telephony cloud, even before we invented the word cloud. If you think about all the attributes of a cloud, telephony service have all of them. And if we compare to what we have been doing with what the phone company have done for the telephony services, we have done much less in the management space, even though we have put a lot of effort in the application space, what the phone company call the data plan or control plan. Right? The management plan is very far behind. And it's very also interesting to think about, given the current world we have shown on the right-hand corner, the far right hand corner, what would be the next would be, what the next step would be. And those has an implication. For example, the first one is a Tanafly. That's also the center, the model for the IoT cloud services, because the Internet of Things essentially is connecting everything to a cloud with a phone company called the Broadband SDN Network services in 70s and 80s. Right? This is all the visions still apply, just the implement technology are different. Okay, and the middle one talks about car, the same thing. When we made the cars before, we are thinking about selling a car. It's like a hard goods transaction. I give you a car, done. You have a problem, you come back, pay me, I will take a look at what's the problem with that. And we see the evolution of the IoT cloud is saying we are changing the notion of this. We are changing the mentality of buying something into renting something. It's really become a service subscription model. This has a big implication. The last one we talk about the banking industry, right? We'll talk about having ATM machine that was a big accomplishment for the banking and financial industry for a while. But these days, people don't even want to go to an ATM machine. Right? They use phones for all transactions. I'm on assignment in China, and guess what? A lot of people there don't even use credit card. A lot of people use phones. They do everything through phone. This is a very different world. Okay. With that said, I believe you have some idea of what you like to see what's next in the future. Now I'm sharing with you some of my personal views on how the evolution will come. My personal view is IoT is really about data. Okay. Data is king. Okay. And if we look at the context for the IoT mobile services, it's really not about the traditional kind of computing-centric notion or data center-centric focused kind of effort, saying how I maximize my CPU utilization, how I reduce my energy costs for the data center. Is really go outside to the world to think about what exactly the society can benefit from the technology. That's what we call the cyber-physical systems, right? And this cyber-systems really integrate the IT technology with our physical world and see how we can make the physical world better. And because of that, we need to focus on the data. Data is really about our physical world. Now, in order to save, analyze, and make action on the data, then this is how the cyber-physical service is about. And you can see that the data grows very fast. So this I want to show you. That's my personal view about cyber-physical. And you see the code very well. And the trend of the IoT services, as many other people have mentioned, and the big value the IoT services and mobile services generate would come from the industrial application. That's really what people have been talking about, Industry 4.0 or Internet Plus. Right, or the fourth industrial revolution, also think about this global industry metamorphosis. This is really the context. And I would like to give you a concrete examples on what we have been doing to demonstrate that a true IoT cloud services really cannot be owned by anyone. And integrating the whole thing together is really the people's problem. The complexity of IoT services is normally underestimated. And in this example, I show you a kind of a connected cars use cases in which the usage-based insurance would exploit this kind of system. Now, as you can see, the data coming from 3 different sources in order to make a whole thing valuable or useful, and including external data, so like weather data, the map data, and the car, the location data. If we only look at the data we collect from a car, the value can generate from that device data is much less when we integrate the data with the other data like the weather and the map. A concrete example would be saying, if I want to provide a usage-based insurance policies for my customers, assuming I'm an insurance provider, right? I would like to know the driving behavior. At the beginning, the insurance company would say, how about we just like a driver to have some OBD sensor collector to collect their behavior, how often they press the brake pedal, how often they accelerate, when they turn, etc. Very soon they found out that's not a good idea. As you can imagine, why? Because people press the brake pedal due to many valid reasons. The traffic is very bad, the weather is bad. If you only look at one data, you cannot make the right decision. That's why we call it contextual data, contextual analysis. This is what we need. Once you start thinking about the contextual analysis, the things become more interesting, but the effort requires more. So this is one kind of example. Another one I want to show you is the data has to come from a communication network, in this case, the wireless, right? Then we get into the cloud, the traditional cloud, IaaS and PaaS. In this diagram, the ones in the yellow, like soft layer, is IBM's IaaS service, and you can see we certainly the infrastructure service layer services and provided to the application layer. In the blue boxes, there's IBM's PaaS platform. It's called Bluemix. In there, I also want to mention to you there's two different kinds of services in the PaaS layer. One is more horizontal, that is the general purpose cross-industry, like a Hadoop and this kind of data analysis, like a data historian services, messaging pops up, those things. There's also industry domain-specific services, like on the upper right-hand corner, those are three things. We call vertical or industrial PaaS. That's really the key drivers for the IoT service now. That's also key driver for the value generation. Okay, and we think we need to spend much more effort in that domain, not staying at the lower level, even though they are still continuing important. But very often, given the current business priorities, those are good enough. Okay, so that's one thing. Now, I also want to say is the end-to-end service assurance, the quality service assurance is really the key. And a lot of people have been not focusing on that, especially for people who are not being exposed to the telephony thing. In the sense that in the computer science, the traditional computer I go from, we are talking about layer, right? Assuming that the lower layer can do everything for me, I build something on top of that. But in reality, it will never work from an end-to-end service perspective because each layer has its own view. And then no layer have a global view on what's going on. So the phone companies or telephony, they have been thinking about a long time ago, saying, besides the so-called consumer-facing or the CPE, customer premise equipment-facing, we need to have a data plan and control plan. The data plan is really talk about data that consumer want to communicate, in that case, voice. They want to give the user, right, a control plan to control what they want, and etc. Then they have a management plan behind the scene can look at all layers. Right now, a lot of abstraction we are building actually make that management plan very hard to realize. So this is something I want to bring people's attention. When we build a layer, think about how we can make a management plan to manage all across, end-to-end, vertical, horizontal. So this is my last slide. That's my personal view on some key technology requirement and trends for managing IoT cloud-enabled cyber-physical service computing. The number one I want to emphasize again, my personal view is when we think about mobile IoT services, our focus should be on the cyber-physical service environment we are trying to manage and optimize, not the computing resources we are trying to optimize. In that case, we need to integrate the sensors, humans, machine, natural resources for the physical world from the modeling perspective. We need to have a good physical model for the cyber-physical space first. Now, in the cyber space, then we need to talk about how we can leverage API design IoT cloud services for manageability assurance. The manageability, as I mentioned again and again, is very key to making a successful service. If we roll out service that cannot be managed, you can bet that service will not live long. Okay. And then that includes the service ecosystem and the intercloud. As I mentioned, since no one can own everything, so how to think about we can have an interoperable intercloud kind of a standard or mechanism, that will be very important. this case, including the fog computing, the fog is a cloud. And I think we can talk more about that is edge computing, this thing. The second thing I want to talk about is really focus on the data and the analytic services for the cyber-physical space. Is the processing APIs, processing-oriented API is needed, but it should not be in the main driver, should not be on the center. The center should be the data services and analytic service we talk about. That should be on the center. And we serve minimum operational service quality level assurance. But the minimum is very important. It's not the maximum, not the best you can do, but what you can guarantee as a minimum. Another is operational. That means it's not the solution or off-the-line analysis, really how you can operate in the production mode. Okay, like a latency we talked about before. Many high-value IoT service people have been imagining have a dependency on the latency, on how quickly you can get the data. If we just think about I can get all the data in the batch mode and do analysis, it's not really the whole big picture. Now, even you do that, how quickly you can finish the work, that's also important, because that may affect your end-to-end kind of a value generation process. And that's what we talk about from raw data to contextual information to finally to domain knowledge. Now we talk about the edge computing, real-time computing also. The last thing I'm keeping saying that our previous keynote talk about, from the programming language perspective, should we think about the data flow language we think about in the 70s and the 80s? It seems that given the focus we have right now and the technology we have today, it's worth to think about what a new language we can develop that's a data-centric, not a processing-centric, right? And that enable better the production time the optimization. Lastly, I want to talk about is really the self-learning technology and service computing in large. The reason why I mention that is the system we're talking about is very complicated. It's very hard to learn all those skills. We talked about before, like all kinds of open sources, technologies, all kinds of problems, all kinds of options. A lot of problems people are facing today are too many options. They don't know how they can work together, choose the right subset for their problem. In order to make that happen, we need to have the sufficient skills and people resources. What are the technology we can invent to help people to acquire those skills? I think that's also mentioned here. And that's why we talk about interdisciplinary and talk about cross-cultural collaboration. What the technology can enable help people to do that. Another thing is how we can leverage the open source, the data and the code, and the benchmarking stuff to help people to learn and understand the complexity of designing a real system for themselves. And last of the thing I want to put there is, as a chair of IEEE Computer Society's Technical Committee on Service Computing, I initiated this open data and benchmarking initiative last year, specifically for this purpose. Because we think when we move from the horizontal infrastructure layer to the industrial high-value generation thing, very often we have a gap. Is people in the industry know the problem, have the data, but don't have the sufficient skills or bandwidth to look at the algorithm. In the academia, people have the knowledge, have the skill, have the idea, but they don't have the data. So hopefully, through this initiative, we can make that happen. Thank you.
Thanks, Ron. So I think you heard from the industry perspective what some of the things we are kind of thinking about, and we'll dig a little bit deeper in the Q&A. But Manish has been, I think this is his third talk for this conference, so probably you should get the award for the most number of talks given in this conference. But thank you for joining the panel. He has been working in cyber physical system, as you know, many of you know, as well as dealing with this large volume, variety, and veracity of the data in scientific computing point of view, as well as autonomic computing point of view. And I think it will be good to hear from him what he thinks the academia is doing and where the intersection is between academia and industry as we go into the Q&A. Manish?
Thank you, Nimish. So it's always a problem when you have to give 3 talks and you have only 1 idea. So I apologize if you've seen these slides before. So it's really nice to go last after my colleagues have very nicely, eloquently articulated the challenges and opportunities of IoT. So I'll try to sort of step back and say, okay, given that we are entering this new world where everything is going to be instrumented, there's going to be a lot of data, how can we think differently about what we do with it? So clearly, as you've seen from the last talk, there's going to be this huge explosion of data sources, right? Everything from devices that you carry or wear to the infrastructure that you're in, they're going to be producing information, producing data all around you. And the idea is to use this data to do something, right? You could think about workflows that are defined that process that data and give you different types of value. You saw some of them in the previous slides. You can think about, well, you saw them in the first three presentations. And this involves transforming that data in some way, right? And here are some use cases. You can think about precision medicine. This is an initiative where you're thinking about how you can use all this data to be able to come up with lifestyle choices to actual treatment procedures that are customized to individuals by using information around both instrument collected from large devices, including data that I get from instruments that I wear. Smart infrastructure, we saw some examples of that before. Disaster management is a good example where you can use real-time information to do interesting things, right? However, this works well if you're thinking about classical workflow scenarios where services are composed, they process the data and do something, right? But if you open this up and start thinking of this notion that we can think of application as things that are more alive, right? That are evolving continuously. As new information comes in, as I walk, along one of the avenues or streets in Manhattan, there's information coming in, and that gets contextualized and adds value to me, to my objectives as I go along, right? So if you start thinking about that, you need to rethink a lot of the paradigms we have, right? The way we build workflows, the way we execute workflows, the whole notion of computing has to change, right? For example, all the data is here, right? But your computing power sits in clouds and data centers somewhere, and that's not really going to work very well. And so one concept there is, realizing the fact that not only is there more data being produced, but there is also a lot of computing that's pervasive that we sort of take for granted now, right? I know there's a colleague of mine, and when I wear my HPC hat, says that his iPhone is more powerful than the first supercomputer that he programmed, right? So the message here is that everything from these small devices have non-trivial capability for processing it, right? How do we utilize them in a meaningful way? And there's so many of them, so we not only have computing power, we have a tremendous amount of concurrency, right? So how can we combine them in some opportunistic way to add value to me, right? And I think that is sort of where this notion of services and IoT can really transform things, right? So I used the slide before, but I think the idea is that think about workflows, but not in your traditional way, but think of them as things that are alive and evolving and adapting on the fly as more information comes in, as objectives change, right? Initially, maybe I'm thinking about how to get to the train station and it starts raining, and then my objective changes, how do I get to this place where I can get some shelter? Or this is a trivial example. You can think about situations where things change on the fly. So you need to be able to really adapt, discover, integrate, assimilate services as you go along, evolve opportunistically, right? You're not always sure you'll get the information, but if it's there, I can use it, right? And as I use it, there's a cost of using it. There's a cost that's going to drain my battery power. There's a cost that's going to take time. So you always have to evaluate whether the value that I'm getting by adding that additional information or doing that additional data analytics, what value does it give me? And is it worth it, right? So this is this constant process of being able to do a cost-benefit analysis, all right? And cost can be interpreted in many different ways, and be able to optimize as I go along, right? And then there's this notion of uncertainty, right? The data that you get has some quality associated with it in terms of its accuracy, in terms of its timeliness, in terms of its resolution, and that's going to impact any decision that I make, right? So I not only have to make a decision, but I have to understand what is the uncertainty in that decision, and can I really act on it, right? If it's true, there's no, right? So there has to be this quantification process, right? So I have an example. I'm going to skip this and just conclude. So I think the opportunity of IoT and mobile services comes into realizing this ecosystem where we have this information rich that is really combining these pieces together very opportunistically, very dynamically to provide value to me or whatever the objective that I'm trying to see, right? And these really evolve as I go along, right? So they're really organic. They have to leverage the fact that not only data is pervasive, but computing is pervasive. You cannot, think that computing is in the center and data all around, and somehow I have to use the static notion of workflows hosted there. But think about computing just as pervasive as data, and then you have to add value not only at the edges and the core, but also along the data path. As my data moves, it gets transformed and processed to make it more useful to me, right? And how do I make that happen, right? So if you combine this with the idea of software-defined ecosystems, you can think about living workflows, software-defined systems, and I didn't talk about autonomic management, but I think a lot of concepts of autonomics that became very popular in the early 2000s come in here, where the idea is that you have objectives, and as information changes, those objectives are evaluated, and the system evolves and adapts to meet those objectives in a more automated fashion, if you may. And clearly, if we want to sort of really transform our applications into these alive entities that run continuously and optimize continuously, right, there are clearly many challenges from how do I conceptualize these things, how do I program them, how do I manage and execute them, what I do in terms of things going wrong, what if I made a wrong decision, how do I correct it, how do I manage the impact, how do I quantify what the uncertainty, any decision I'm going to make, and there are a lot of things, how do I make sure things work together. So clearly, it's a rich agenda. I'm going to stop here, and thank you.
Great, thanks, Manish. I know it is hard to come up with lots of good ideas after 3 talks. I think that's a tall order for a professor, not just otherwise. So I think you heard many things in terms of maybe there is a paradigm shift here when you look at the IoT and mobile. The service-oriented computing, the cloud computing, big data has come mainly from best effort kind of services, as well as many of the enterprise applications, such as ERP, SAP that Teresa talked about. And what you're hearing is this transformation to this operational dimension of the society. As I talked about in the beginning, the network society where you have everything is connected, and now you're not just trying to provide best effort search, and who cares what the search is, it comes a few minutes late, it's okay. But that will not fly when you need to run the IoT systems, when the operation system. So we need to think about this constraint-based paradigm that we are entering into in terms of where the 95% of the data is going to come from. That's the dark side of the data, or dark data as IBM used to call it, I believe. And that's what the opportunities are in terms of where you can make real impact to the society, where you can make the transformations. So the computation paradigm has to change. It is, I think Manish talked about this objective-based computation and autonomic aspects. Now we are looking at a real-time system that can be managed in this capacity, in this way. And Teresa talked about some of this semantic modeling, as well as, I think at the end of the day, the user has to be able to interact with this data and with the insights that Robert talked about. So it is now we are in the operational dimension where a lot of things that are at stake, not just money, but people's lives. Your self-driving car and your ride within that car is at stake. You can't just say, well, it's okay if I miss a bit here and there, because that will not fly, especially in New York City, if you know what I'm talking about. So I think this kind of things are the challenge, I think, to the academia and for us as an industry is what is this new paradigm? And the one that we have been on for the last 15 years, is that the one that will get us to the next 15 years? And I think the answers are not there yet, and that's where we need more help. But maybe I'll start some questions, and please feel free to come up to the mic and ask the questions. So I think, Teresa, you talked about this domain modeling. So I think Tim Berners-Lee had worked on the semantic web for a long time. What's your take on how that approach worked or didn't work, and what should be done? Anybody else has any thoughts on semantic web and semantic modeling? Yes, go ahead. And Ron, you talked about this data initiative that you have. Do you see need for new kind of benchmarks and new standards, or what's the thought?
My thought is, I've got a nice feedback already. Some people think that all the data we need for and most other people think that you cannot find data they need for problem with the database. So my thought is that in order to make that happen, we need an industrial to work with even business together. And one of the scenarios now is the industrial formalize only the business problem the industry is facing, and as well as the data that you share with academia, not necessarily working, but some form of the data formalizing into the benchmark or the SF, so that academia can understand better of the challenges you are facing for industrial applications in the IoT space. And then figure out the algorithm, right? Since we are about open data, benchmark, etc., then the industry most benefit from the opinion institute stuff. They can apply any algorithm for their own private data if they like. As long as the nature of the problem is well understood through the open data stuff. This is my wish that this collaboration can happen. But right now, I think there's a lot of
Okay. So I think this is like a class. So it will be dismissed at 6 o'clock exactly. So either you can come up with the questions, or I keep on asking questions. So you have still 6 more minutes to ask more questions. But I think, Robert, you talked about this Google Glass. Go ahead. Yes. Mm-hmm. Any thoughts on this kind of APIs and systems of systems kind of a discussion, I think, Paul? Yeah, I think Teddy said, but you talked about this data as being referenced through semantic rather than any other way. Any thoughts on that? Yes, go ahead.
Well, we've seen a lot of comments on that talk about related to our services and but if you talk about the IoT devices that are important for yourself, so being security for myself, my concern is given the fact that these IoT devices are really user constrained, so that we have so it's not exactly that easy from those tiny devices. So do you see in the industry standards coming out which probably maybe manufacturing and probably working across devices in addition to the service protocols for NBC security protocols for so that the data is reported can actually be verified.
Well, we have worked with that I think as much as possible, they have been using HPS but do the communication. Now, if that was scaled to little smaller lines or not, is another question. Good point. But as much as possible, try to isolate to being firewall and things like that. So I think that there's still a lot of space for that, and still a good question in that area. So we will mention the work.
And I think there are standards like COAP that probably you're aware of, but that doesn't deal with security as per se at this point in time. And I think going back to Manish's point of this being the supercomputer, the form factor for many of these devices and type of computation and customization that you'll be able to do, like I think ARM has now put a secure chip at the sensor level. So does Intel for their Core chipset. So there are, I think, ways to deal with the security, but you're right. I think that will be a challenge, and some of the things that Ericsson is doing is extending the security from the network domain to the devices, and how we can have a proxy model that can help to deal with encryption as then and compliance of the data as it flows through the network. So with the last question, I think maybe for Roberto, I think you talked about the visualization aspects. How do you see this evolving from the end user point of view? I think you have this Google Glass or some glass kind of paradigm to virtual reality to theater-sized NOC visualizing the data. How does that continuum play out?
Well, that's a challenge. We probably provide those big data and have to build devices and have control of the device. So actually, our approach is being by adopting different types of visualization, by making those things so factual as Ray said, by filtering out the relevant information given the existing context. And then as we get more and more able to understand the user context, then you can filter out the information, then you can tailor it out, then it becomes sustainable to show this with those small devices. But of course, there's always a need for some new things, and we have to experiment with visualizations. Like from this stage, we already need some data, then do some exploration. So I think there is room for both of them, but the context is figure out. The question is not the actual context of the models and how can we get the right information.
There's contextual, semantic, autonomous, AI, and all the things that you guys can help us with. But I think I'll stop there. Is there any other question? Thank you for the panel. certificates for them?
No. For papers.
Ah.
Yeah, I need to start.
Thank you.